Hello everyone. In this video, we're going to see the solution for the Codechef problem strange number, which is a part of April Challenge 2020. It is live right now, but I'll be posting this when the contest ends. So basically in this question, we're given two integers x and k, and we have to find whether there's an integer a such that it has exactly x positive integer divisors and exactly k of them are prime numbers. And that's pretty much it. We're given test cases and we have to find if a number exists such that it has x total divisors and k exactly k prime divisors. So let's get started. So the question is quite simple, although it took me a lot of time to get to the final solution. So I'll explain to you my approach and I'll also give a link to my code in case you want to look at it. So let's get started. So x is the total number of total divisors of a number, suppose a, and we have to find whether a exists or not. And k is the prime number of prime divisors. Prime divisors meaning that the divisors which are prime. So we have to find whether such a number a exists or not. So this is for a. For a, x total divisors and k prime divisors. Now you should notice that it says exactly. So it should have exactly k prime number divisors. So let's take an example. Suppose k is equal to 2. So that means that a has exactly 2 prime divisors. Now those 2 prime divisors can be anything, but for simplicity I'll be taking the first prime numbers. So let those be 2 and 3. So a has 2 and 3 as prime divisors. Now, so that means that 2 and 3 are the only prime divisors of a. So that means that a can be divided by 2. A can be divided by, so a can have 2 as divisor, a can have 3 as divisor, a can have 6 as divisor also, a can have 4 as divisor also, but a cannot have 5 as a divisor because 2 and 3 are the only prime divisors of a. Now, so from that you should get this, that a will be in the form 2 to the power x into 3 to the power y. And if you've gotten this, then the question is pretty much finished. So a has exactly 2 prime divisors as k is equal to 2. So taking those 2 prime divisors as 2 and 3. So a will be in the form 2 to the power x into 3 to the power y, because a should be divided by 2, and if it's divided by 2, then it can be anything. It can be 2, 4, 16, any power of 2. And likewise it has to be divided by 3, so it can be any power of 3, 9, 27, it can be anything which is the power of 3. But it cannot be a multiple of any other prime number. So it will be in the form 2 to the power x into 3 to the power y. So if I take k is equal to 3, so a will have exactly 3. A has exactly 3 prime divisors, and taking them as 2, 3, 5, 2, 3, 5. So a will be in the form 2 to the power x into 3 to the power y into 5 to the power z. So if k is equal to 3, then a will be in this form. So this is something that you should be able to get from just k. Now moving on this, suppose that k can be anything now, and I'll just put in one thing that you should know for this. So suppose there's a number n, and n is in the form a to the power p into b to the power q into c to the power r, c to the power r. If there's any number n, if n can be represented as this, n is equal to a to the power b, a to the power p into b to the power q into c to the power r, where a, b, c are prime numbers and distinct, of course, and p, q are respectively their powers, then total divisors of a, total divisors of n, sorry, total divisors of n will be 1 plus p into 1 plus q into 1 plus r. So if any number n can be represented as this, where a, b, and c are prime numbers, then total of divisors of n can be found using this formula. Now, once you know this, or once you've found this, you can get back to the question. So, like I said, we've come to this point that a can be in this form. So, for taking k, a will be this form. Likewise, if k is anything, suppose k is n, then a will be 2 to the power x. Then first of all, the total divisors will be 2, 3, 5, 7 till n if k is equal to n, meaning that n prime numbers as divisors. So let those be 2, 3, 5, 7 up to the nth prime number. Okay, so a will be in the form 2 to the power x into 3 to the power y into 5 to the power z, and so on till the nth prime number to the power something. So a will be in this form. So let's get back to the simple example where k is equal to 2. So a will be in the form 2 to the power x into 3 to the power y. Now you can deduce from this n is equal to n is in this form, and here a is in the same form. So that means that total divisors of a will be 1 plus x into 1 plus y. And do know that x and y will both be greater than or equal to 1, because if any is 0, then it won't be divisible by that number, and it has to be divisible by 2, and it has to be divisible by 3. So x and y should at least be 1. So they should be greater than or equal to 1. So if k is equal to 2, then total divisors of a will be 1 plus x, 1 plus y, where x and y can be any numbers greater than or equal to 1. So which means that suppose that the total number of divisors of a is x. If total divisors of a is capital X, don't confuse it with this x. So if total divisors of a is capital X, then x should be of the form 1 plus x into 1 plus y, like we've deduced before, because if k is equal to 2, a has exactly 2 prime divisors, and a has 2 and 3 as prime divisors, and 2 and 3 are the only prime divisors of a. So a will be in this form, 2 to the power x into 3 to the power y, and from this formula we found that the total divisors of a will be 1 plus x and 1 plus y. So if total divisors of a is x, then x will be in the form 1 plus x into 1 plus y. Now this means that x should be of the form, say, a into b, where a is 1 plus x and b is 1 plus y. So it means that x should be product of two numbers. If it is not, then it's not possible. So likewise, if k is equal to 3, then x should be a product of three numbers. You can check out for the example k is equal to 3, taking 2, 3 and 5 as the prime divisors. So this can be generalized. For k, for capital K, x should be a product of k numbers. And that's all we needed to know for the answer, because they're given x and we're given k. So we have to find if x can be represented as product of k numbers, then a is possible, else a is not possible. So that's pretty much it. And to find if x can be represented as a product of k numbers, find the uh, prime factorization of k of x, prime factorization of x, and find the total powers of the primes of the factorization. And if total power greater than or equal to k, then x can be represented as a product of prime numbers, else it cannot. So that's what I've done in the code. So I've taken in x and k, and then I've gone from 2 to root square root n x, and if x is divisible by I, then I'm increased count, which is the power, and then if count is greater than or equal to k, then 1, meaning that yes, otherwise 0. So to revise, if a number has k prime divisors and k is equal to 2, so it will be in the form 2 to the power x into 3 to the power y, and the total divisors will be 1 plus x into 1 plus y. And if total divisors is this, then total divisors should be represented, should be able to represent it as product of two numbers. And for that, we'll find the total number of power of its prime factors, and if total power is greater than or equal to k, then the answer exists. If it doesn't, then the a doesn't exist, the answer is not there, a doesn't exist. So the approach was pretty simple, and you can also check out my code. And if you have any doubts, then just post it in the comments. I'll be sure to answer. Thank you.